All right, today we're looking at multiplication properties of exponents, beginning on page 450 on the textbook. We're using properties of exponents to multiply exponential expressions, and we're going to use them in a real-life problem. First thing you have is the actual properties listed for you. It says let A and B be numbers, and let M and N be positive integers. So A and B can be any number, and M and N, we're only going to talk about positive numbers, and we're only going to talk about numbers that are not fractions or decimals, so positive integers. The first one is the product of powers property. A lot of P's in there. To multiply powers having the same base, in that first blank we're going to write add the exponents. So if they have the exact same base, you add the exponents. The two examples given to you are a to the m times a to the n. Again, there's no numbers listed there. You simply, since the key right here is that the base is the same, they're both exactly the same a, then you just add the values m and n. So m plus n. Looking at numbers, both of these have the exact same base. They're both 3. You simply add 2 plus 7 and you get 3 to the 9th. That is the product of powers. So that means multiplying the same base. The next one is raising a power to a power. Notice it's real similar sounding, but the difference is you're raising a power to a power. When you find the power of a power, multiply the exponents. So if you have two things multiplying by each other, 2 to the second times 2 to the third, same base, anytime it's the same base, you add 2 to the 2 plus 3 and you get 2 to the 5th. When you're multiplying the exponents, notice it says a to the m to the nth. That's how you read that, a to the m to the n. Now that sounds like a rap song, but it's not. A to the m to the n, you just multiply m times n. Notice the difference, how it looks here compared to how it looks there. Notice the difference in how they're set up originally. When you have numbers 5 to the second to the fourth, you're going to multiply 2 times 4 to get 5 to the 8th. That's the difference. When you're multiplying the same base like this, you add 2 plus 3. When you're raising a power to a power, you multiply 2 times 4 in that case. And then the other one is the power of a product property. You find the power of each factor and you multiply. So right here we have a times b to the m. Our order of operations tells us we need to multiply a times b first. Well, this is an alternative to that. If that is difficult for you to do, a times b to the m, and most of the time it'll be difficult when you're talking about a variable that you can't multiply, and we know how the distributive property works. You have to distribute it to both things. Like right here, you could multiply 2 times 3, but the reason they're showing you this is to show you that it's the same thing. An even easier one would be, let's say if it said 2 times 3 and it just raised everything to the second power. That's easier for people to see. We know 2 times 3 inside would be 6, and we know when we raise 6 to the second power, we get the number 36. However, if you did it this way, like it's saying here, 2 to the second power times 3 to the second power, 2 to the second power is 4, times 3 squared is 9. 4 times 9 gives you the same 36. That's just a way showing you that it works both directions. Those are the 3 properties that we're talking about for today. Example number 1. You have 4 to the third times 5 to the 5th. You add 4 to the 3 plus 5. For B, you have variables. There's no bases that are values. You don't have a number like 4. However, it is the same exact variable. It's exactly the same. All of them are y, y, and y. The bases are the same. So you can add 4 plus 5 plus 6. You get 4 to the 8th, and you get y to the 15th for those. The next two, 6 squared times 6. This will be one that people make mistakes on right here because they forget that there's an exponent written right there. Just like you can multiply anything times 1, just like you can put everything over 1, if an exponent is not shown, it is known to have 1 as its exponent. In the power itself, it's exponent is 1. So you would add 2 plus 1 for C, and you'd get C to the 6 to the third power. For D, the same thing. You have negative 3 to the first power. That first power is not shown. If you have to write it in, you need to write it in to see it. And you add 1 plus 7. Even though there's negatives, you still add 1 plus 7. So you have 2 plus 1 for 6, and you have 1 plus 7 for negative 3. So you get 6 to the third and negative 3 to the 8th power. Copy these 4 down and work these 4. I'll go over them in just a minute. You do not have to evaluate the power at the end. Just leave it in exponential form. Okay, let's take a look at them. For A, it says 4 to the 5th times 4 cubed. You add 4 to the 5th plus 3, and you get 4 to the 8th power. This is what I mean by you didn't have to evaluate it. You could leave it in exponential form. 5 plus 3 is 8. That takes the tough part away, and at the same time, that's what calculators are for. Had you wanted to go ahead and simplify this, you can write 4 times 4 8 times, or you can plug into your calculator 4 raised to the 8th power. That's what that button right there means. It's called a caret button. It means raise it to that power, and you get a great big number when you do that. However, for B, it says y to the 3rd times y to the 4th times y to the 5th. All of your bases are the same, y times y times y. So you have y to the 3 plus 4 plus 5. 3 plus 4 is 7, plus 5, y is to the 12th power. Letter C says 2 times 2 to the 6th. What you have to remember is that any exponent that is not shown is known to be 1. So that says 2 to the 1st times 2 to the 6th, which is 2 to the 1 plus 6, or 2 to the 7th power. And then that last one says negative 5 times negative 5 to the 3rd. Again, it'll look like this, negative 5 to the 1st times negative 5 to the 3rd. Exact same base, negative 5. So you have negative 5 to the 1 plus 3, or negative 5 to the 4th power. Example number 2 looks like this. Now, example number 1 was multiplying the same base. Example number 2 is raising a power to a power. So for A, you have 7 to the 3rd to the 5th. That means 7 to the 3 times 5, which gives you 7 to the 15th. For B, you have x to the 2nd to the 5th, or x squared to the 5th. That means x to the 2 times 5, which is x to the 10th. Same thing with C and D. For C, you have negative 2, to the 4th cubed. You have negative 2 to the 4 times 3, which is negative 2. Notice it's still in parentheses here, to the 12th, because 4 times 3 is 12. Anytime you're raising a power to a power. Where the only mistakes people make with this is they get the two confused. They multiply when they have like 2 to the 1st times 2 to the 3rd. They multiply 3 times 1 right there. That's not what you do. You add those. And then they'll have 2 to the 2nd to the 3rd, and they'll add those two, 3 plus 2. That's not what you do. Don't get the two confused. And then b minus 1 to the 6th to the 4th is b minus 1 to the 6 times 4, which is b minus 1 to the 24th power. Copy these 4 down. Do these. You got to give you a minute. Again, leave them in exponential form. You don't have to evaluate the last step. Okay, A says 5 squared cubed, or 5 to the second to the third. That means 5 to the second times 3, which is 5 to the sixth. If you added those right there, make sure you make that change. Raising a power to a power, you multiply. Same thing with B, except now there's no number like 5. You have x, but it's still x to the third to the second, which x to the 3 times 2, or x to the sixth power. Going fast through these because it doesn't take but a second to do them. Negative 2 to the third to the fourth is negative 2 to the 3 times 4, which is negative 2 to the 12th power. And then the last one, a minus 2 to the third squared, a minus 2 to the 3 times 2, or a minus 2 to the 6th power. Again, that's powers to powers. For example, number 3, this is using the power of a product. So you have 2 times 3 cubed. You can do 2 times 3 within parentheses. That's what order of operations tells you to do. But when you have different values, it's hard to do that. Or when you have exponents, or when you have variables plugged in, it's hard to do that. So you have a times 2, 2 times 3 to the third. It's 2 to the third times 3 to the third, which 2 to the third is 8, and 3 to the third is 27. And when you multiply 8 and 27, you get 216. Now this is evaluating them and multiplying to simplify at the end. B is 9xy squared, which means 9 times x times y. That just expanded it to where you can see it, which is going to give you 9 squared times x squared times y squared. Another way you can look at this is you have to distribute the variable. That's not a technical term to say to distribute it, but that's what's going on. You're giving one of those squares to each thing inside of the parentheses. So 9 squared is 81 times x squared times y squared is your simplified version. And then C says negative 3z to the fourth is just identifying the factors of it. If you didn't have that written in there, go ahead and write that in there. That's just negative 3 times z. That's just expanding it out. And then you do negative 3 to the fourth power times z to the fourth power, raising each factor to a power, which negative 3 to the fourth power means negative 3 times itself 4 times, which is 81, z to the fourth power. And then D, negative, notice where the negative is for this one compared to C. 4w to the third power. When you identify the factors 4 and w, you give each one of those a third power. So you have still that negatives out front. 4 to the third power is 4 times itself 3 times, which is 64. W to the third power, and then the negative comes down in front of it to make it negative 64w to the third power. And that's just simplifying it at the end. Copy these 4 down. Do the same thing. Give you a minute. Okay, for these problems, you have 3 times 4 squared. You could do 3 times 4 and get 12 squared, but if you're following the product that the property we're using right now, you would say that that means 3 squared times 4 squared, which 3 squared we know means 3 times 3, and 4 squared we know is 4 times 4. And when you multiply 9 and 16, well, we know 9 times 6 is 54. 9 times 1 plus 5 is 144. The same 144 you'd have got 3 times 4 and then squared it. For B, you have 3 times x times y to the fourth. What you need to know is that you give the fourth power to everything. So 3 to the fourth power times x to the fourth power times y to the fourth power. So the exponents are going to stay the same. You're going to leave, the variables x to the fourth, y to the fourth are going to stay the same. The only thing you have to evaluate out is 3 to the fourth power. 3 times 3 is 9. Times 3 is 27. Times 3 more gives you, if you do it 4 times, gives you 81 x to the fourth, y to the fourth. For this next one, it says negative 3 y squared. You're given the square to the negative 3. Now, this acts as if it says negative 3 inside parentheses since you're giving it inside of the parentheses. A negative times a negative is going to be a positive. 3 times 3 is going to be 9. Y squared is going to be y squared. Notice the difference between that one and this one. Now the negative is outside. So when you give the square to the 3, it's 3 times 3, which is 9 again. When you give it to the y, it's y squared, but then the negative comes down in front of it. So that's the difference between C and D, the positive versus the negative. And then the last example, number 4, is using all three properties together. 7w squared z to the third squared times z to the fourth power. So what you're doing for this whole first part here, before you get to where it multiplies by z to the fourth, you're raising powers to powers. So you have to make sure that the squared goes to everything. The square has to go to 7. That's what we have here, 7 squared. The square has to go to w squared. Remember, you're raising a power to a power. You have 2 times 2. And the square has to go to z to the third. Again, a power to a power becomes z to the 3 times 2. And then it's multiplying times z to the fourth. So we have here 7 squared is 49. W squared squared gives you w to the fourth power. Z to the third squared means 3 times 2, which is z to the sixth power, and then it's z to the fourth power. So the last thing you have to do to evaluate is you have to multiply these same bases, which means you add the exponents. So you add 6 plus 4 right there, and you get this part here, z to the 10th. Notice the rest of it's the same, 49 and w to the fourth times z to the 10th power. You do not multiply 6 times 4 right there, since you're adding the exponents, since you're multiplying the same bases. And then copy this last one down, and then we'll get to the checkpoint. Okay, let's take a look at this one. Didn't need quite as much time for this one. When you look at 3x to the fourth y squared, you have to make sure to square everything inside of that parentheses. So what you have is 3 squared times x to the fourth squared times y squared. We'll write it in the same fashion. So 3 squared we know is 9. X to the 4 squared means x to the 4 times 2, which gives you x to the 8th power. And then y to the 1, it's there, even though you can't see it, times 2 is y squared. And then bring down your y to the 5th. So just like the last one, instead of multiplying 2 times 5 at the end for this last part, you do y to the 2 plus 5. That'll be the part that'll get you on this, because you have to go back and forth with it. So you have 9x to the 8th, y to the 7th power. Then we had some checkpoints at the bottom. It says negative 4 to the 3rd power times negative 4 to the 6th power. Exact same base, negative 4. You add 3 plus 6, and you get negative 4 to the 9th power. W to the 10th power times w. Don't forget that there is a w to the first power. So that means w to the 10 plus 1, which is w to the 11th power. And then d to the 4 to the 4th to the 5th power. Notice now, instead of multiplying the bases, now you're raising an exponent to an exponent. So you're not going to add 4 plus 5 right here. You're going to do d to the 4 times 5, which is d to the 20th power. For 4, 5, and 6, we have 6p squared. You have to make sure both terms have the square. 6 squared times p squared And 6 squared, I don't know if it goes out to 36. 6 squared means 6 times itself, 36p squared. There'll be times when you evaluate out that last step and times when you don't. For number 5, it says negative 2 to the fourth power. So that means negative 2 to the fourth power. You have to make sure everything else has the fourth power as well. X, that's a distributed, x to the fourth power, y to the fourth power. Each of those are 1, so it'll be 1 times 4, which gets us right back to 4. Negative 2 times negative 2 is positive 4, times negative 2 is negative 8, times negative 2 is positive 16. It gets you back to 16, x to the fourth, y to the fourth. And then the last one, you have to give the fifth power to everything. 2 to the fifth power times w to the fifth power times z to the 2 times 5. Remember, time you're raising an exponent, a power to a power, you have to multiply. And then it's saying times w squared times z squared. So when we evaluate all this out, 2 to the fifth means 2 times itself, 5 times 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And then you have w, we'll simplify this part out real quick, w to the fifth, z to the 10th, times w squared, z squared. Put your like ones together. W to the fifth times w squared means 32, w to the 5 plus 2. And z to the 10th times z squared means z to the 10 plus 2. So simplify it out, 32w to the 7th, z to the 12th. These are very easy for most people, but there's a lot of room for you to make mistakes on this, so make sure you're paying attention to each part.